is branch out. So we're going to branch off quadratics. Firstly, we know what is a quadratic. We got ax squared plus bx plus c. All right, that's what quadratics is. It's x to the power of 2. That's how we know we're dealing with a quadratic. We also know with quadratics, it's a parabola by graphs. So it's going to be a parabola, which can be a Z-shaped parabola or a smiley-shaped parabola. Then you get quadratic equations. And quadratic equations, you can get the type where you have it in the form which you can factorize. So for example, let's suppose I've got x squared minus 2x plus 1 equals 0. This is x minus 1 equals 0. So therefore, x equals to 1 or x equals to 1 for each of those. And that's when you can factorize it. When you cannot factorize, so this is when you can factorize, then you use the quadratic formula. All right. So if you can't factorize, then you would use the quadratic formula. And the quadratic formula is minus b plus minus the square root of b squared minus 4ac over 2a. And that only gets you your x values, right? So that's the quadratic formula. Quadratic formula in cases where you can't factorize it. So for example, I got 9x squared minus 8x plus 1. Hypothetically speaking, I'm not sure, maybe you can factorize that one. Try another one. Let's say 11 equals 0. So from there, I can see, if I look at another example, so I got equations, I got the graph itself as a function, and I can also have quadratic equations where they might not have three terms. It can just be like x squared minus x equals 1, for example, in which case we factorize, equals 0, and in which case we'll just factorize x out and then a bracket. And when x is alone, we must remember x can equal 0. When x is with a number, it's always the opposite sign. X equals positive 1. We also have the case, for example, if I factorize something that ends up, let's say, as x minus 4, x plus 4, x minus 3, or x minus 3, x plus 4, it's always the opposite sign that x is. So x equals to 3 over here, and x equals to negative 4 over here. Then you get the case where you have a quadratic x squared minus 1 equals 0, and you got to solve it. In this case, it's a difference of squares, so you can factorize it as a difference of squares. And so x can equal 1, or x can equal minus 1. Or you could simply just move the 1 over to the other side, change signs, and then square root both sides. And once you square root both sides, you're going to end up with x equals to plus minus 1. So plus or minus 1 for that. All right, so that's going to be quadratics in a nutshell in terms of quadratic equations more than anything that we want to actually look at for this. The other thing is when your a value is negative, it'll end up as a sad face, like negative x squared plus 4, for example. And when a is greater than 0, like let's say 2x squared minus x plus 1, then it would be a smiley face. So when that value there is positive, and when that value is negative, it goes sad and it goes smiley. When it's sad, it has a maximum. And when it is smiley, it has a minimum value. And that's the lowest value that it can get to. Other parts of quadratics is completing the square. When you complete the square, you rewrite the quadratic into the form y equals to ax minus p squared plus q. And that's the turning point form because the vertex coordinates will be pq. What's the vertex? The vertex is that maximum point over there that you get to. So that's the vertex, that dot, that coordinate there is pq when you rewrite it in that form. All right, so you get different types of quadratics, the graphs, the general formula, etc. The ability to factorize it and also understand that the x-intercepts is your roots. And that's what you want to find. So when you visualize a quadratic, and let's say, or a parabola, and you have some kind of visual of specifically a parabola, and let's sketch one over here. So let's say I've got one that's like that, right? Let's just see if I can. But neater, there we go. So we go y, we got x over here. Let's make this number 4, and let's make this one -1, and let's make this number -2. If I want to find the equation of this parabola, I can start with the standard form, and the standard form can be written as a turning point form, in which case we complete the square to find. All right, so to do that, we complete the square, and we can have it in the form of y equals a x minus x1 times x minus x2. This is the case where you're given the x-intercepts, and you can see in this particular example, we're given the x-intercepts. There's the x-intercepts over there, x1 and x2. So those are my two x-intercepts. So I'm going to use this form over here to get the equation. So I'm going to write it down. We've got y equals a x minus x1, x minus x2. And so y is equal to a x minus x1. We know x1 is equal to -1. So if we write this as a bracket, we can just move it across. It becomes +1 equals 0. So this should be +1, because remember, it's the opposite of +1 is -1. And then over here, I've got x minus 4, which would get me +4 over there. Okay. I need to find the a value, so I'm going to substitute any other point that lies on this curve. And I can see another point over there. The coordinate of this point over here is 0, -2. And so if I make y equals to -2 and x equals to 0, I will end up with -2 equals a 1 times -4. That's -4a. -2 over -4 equals a. And so a equals to half. So therefore, I can get this equation, my final equation, which would be y equals to a half, which is positive, by the way. So this is a positive a value, and it therefore must be smiley with a minimum. And yep, it is smiley. It has a minimum. So half x plus 1, x minus 4. I can multiply this out and get it into standard form, ax squared plus bx plus c, if I need to. So that would mean keep the half aside. First, multiply the bracket out using FOIL. So x times x would get you x squared minus 4x plus x minus 4. And that would become a half x squared. That over there is minus 3x. So minus 3 over 2x. And then half of 4 is 2. So minus 2. And that would be in standard form of a quadratic or a parabola. Okay, so that's the parabola, particularly looking at the graph and finding the equation as well. Let's move back into quadratic equations now. And let's see if we can solve some of these quadratic equations. All right, so question 1, I've got x squared minus 9 equals 0. Grab a blank piece of paper and see if you can solve this one at a time. Five questions. Notice each of these questions, each of them are equal to 0. So we want to find the x values that will satisfy each of these. Could be two values, could be one value. All right, give it a go, and let's see what you got. Remember, we're solving for x over here. So let's have a look at that. Only x. So solve for x. So for the first question here, what we have is a difference of squares factorization, in which case I would break this up into two brackets, and I've got x over here, I've got x over here, 3 here, 3 over here, plus and minus, and so therefore x will equal -3, or x can equal +3. For the next one, I can take out x out of the bracket. I get x left plus 4 equals 0, and I'm now left with x equals to 0, and or x equals to -4. We can factorize both of them so far. The third one, let's see, can we factorize the third one? So this is x times x gets me x squared. 6 times 1 will get me 6. But I need to get to -5. So if I put -6 and +1, I'll end up with -5, but then I'll end up with -6. If I put +6 and -1, I'll end up with -6 and +5. So definitely 6 and 1 can't work. Let's try 3 and 2. 3 and 2 looks correct, so that's going to be two negatives. Gets me x equals to 3 or x equals to 2 for that. For the next one, it doesn't seem like I could factorize this because there's no two numbers that can multiply to get 4, but at the same time subtract or add to get -6. I would jump into the quadratic formula for this one. Maybe just write it down and have it ready. So I can see my a value is equal to 1, my b value equals -6, my c value equals 4. And so from here, what I'm going to do is substitute it in. So minus -6 plus minus the square root of b squared, which is -6 squared minus 4ac, 4 times 1 times 4, all divided by 2 multiplied by 1. What I'm noticing is that this one here is going to become 6 plus minus the square root of, that's 36, and that's 16, so that's 20 over 2. And that'll give me two solutions for this. Two solutions for x. And the answer that we get here is 5.24. So x equals to 5.24 or 0.764. X equals to 5.24 or x equals to 0.64 to three significant figures. All right, for each of those. And we now move on to the next one. The next one, we have an a value. Can we factorize this one over here? A value is equal to 2, b value is equal to -3, and c value is equal to 5. If I put it into the same formula, it's going to be -3 plus minus the square root of b squared minus 4ac, -3 squared minus 4 times 2 times 5 over 2 times 2. And this ends up as 3 plus minus square root of 9 minus 4 times 2 is 8 times 5 is 40 over 4. And this is a different solution as well. So this one's going to get us 3 plus minus the square root of 9 minus 40 is -31. All right, if my counting is all correct everywhere, then that looks good. But what's the problem with this one? We can't do this one. All right, we can't square root a negative. So for this question here, the actual answer is going to be no solution, which is actually a solution. The solution is no solution. All right, and so we end up with that for that one. All right, so let's do another round. Here we go. So let's do a few questions from this. It's going to be question 1. I've got 3x squared minus 27x equals to 0. Don't forget, for these we are solving for x. Question number 2, I've got 3x squared plus 2x minus 7, all right, equals 0. And let's see if we can solve for x for each of those. Okay, I'll just put question 3 as well. Maybe you can do x squared minus 11x plus 30 equals 0. Okay, let's go through these now. Okay, so here we go. The first one over here, we're going to take out a common factor of 3x. And that's going to leave us with x minus 9, because 3 times 9 is 27. Remember, when x is outside the bracket, it doesn't matter what is in front of the bracket, whether you have a number in front of the bracket or if x is alone or not. You can see that that would always be equal to 0, because 3x equals to 0, so therefore x equals to 0. Then from this side, it's the opposite sign, so x equals to positive 9. For the next one, can we factorize it? Can we put 3x and x and maybe 7 and 1 and maybe get the middle term? No, we can't. So factorizing this is not good. It gives us no option but to use the quadratic formula. So a equals 3, b equals 2, and c equals negative 7. And that's minus b plus minus, so minus 2 plus minus the square root of b squared minus 4ac. That's 2 squared minus 4, 2 squared minus 4 times 3 times negative 7 over 2 times 3. That becomes negative 2 plus minus the square root of, that's 4. 4 times 3 is 12. 12 times 7 is 84. And 84 plus 4 is 88 over 6. And that'll give me two answers over there. Negative 2 plus root 88. So we grab a calculator, put it in the calculator, and put your fraction button. Then go negative 2 plus minus. Do plus first. Press the square root button. 88. Denominator 6. You'll get 1.23. And then keep it in your calculator. Just simply change the negative into positive into a negative. You'll get the second solution in an instant. X equals to negative 1.896. 1.90 rounded up to get that. All right, so that's my two x values for that. For the next one over here, we can factorize this one over here. So we'll have x over here. This one we're going to get 6 and 5, negative and negative. So x equals to 6 or x equals to 5. And this one is factorizable as well for this. To the next question now. So the next question over here, I have the following, a quadratic that looks like this. And I want to solve this quadratic. They tell me that this value is negative 5. I'm calling this one x2. I'm calling this one x1. And they give me another point over here, which is, let's say, 6 and 4. And I am asked to find the equation. So we want to find the equation y equals ax squared plus bx plus c for this. All right. There's probably more information that we might need before we can solve this. So there's another point, let's say, that it goes through, and it's given maybe somewhere over here. And that number is negative 3 and negative 3. Okay, so it's got to go through all three of those points. Let's see what we can do to solve this question here. All right, random question. The first thing I'm going to do is I'm going to substitute 0, negative 5, which is over there, all right, into my equation, all right? So that's going to get me y is negative 5 equals a times 0 squared plus b times 0 plus c, and that's going to be negative 5 is equal to c. So I've got the c now. All right, I got the c value, which is going to be negative 5. Once I've got that now, the next thing I need to do is I'm going to substitute the point, one of the other points, let's say 6 and 4, into y equals ax squared plus bx minus 5, because I know what c is now. And remember, x is 6, y is 4. So this is going to be 4 equals to a times 6 squared plus b times 6 minus 5. I'm going to move the minus 5 across and get an equation. And this is going to be 36a plus 6b. And I can divide each of these values by 3 as well, getting me 3 equals to 12a plus 2b. Equation number 1. Okay, next one. I am going to substitute. So I've done substituting this point. I've done substituting this point. Now I'm going to substitute negative 3, negative 3. Okay. And so here, I'm going to substitute negative 3 for x and negative 3 for y. And it becomes negative 3 equals to a negative 3 squared plus b times negative 3. And c, remember, is still negative 5. So we put that in there. Bring it across, it becomes positive 5, which makes it a 2. This becomes 9a minus 3b. I'm going to call this equation 2. Now I'm going to take these two equations and I'm going to solve it simultaneously. All right, there's going to be a simultaneous equation solving happening now. Okay, so simultaneous equations is where we need to be heading into. So I'm going to take the first equation right over here. 3 equals 12a. Maybe I can go with above. 3 equals 12a plus 2b. And 2 equals 9a minus 3b. Using the process of elimination, I could now try and get the coefficients of either a or b the same. If I multiply this by 3 and I multiply this by 2, then I'll end up with 6b and 6b. And if I keep multiplying by 3, I would end up with 9 equals 36a plus 6b. Multiplying this one by 2 gets me 4 equals 18a minus 6b. And now I can eliminate these two. I can subtract them. 9 minus 4 is 5. 36 minus 18 is 18. And 6 minus minus 6 is going to become positive 12b. And it's an error. All right, so I should not subtract this. I should be adding it. All right, because if I add it, these two eliminates. And then 9 plus 4 is 13. 36 plus 18 is actually 54a. And so 13 over 54, a fraction, that's what a is. In order to get b, I'm going to substitute a equals 13 over 54 into equation 2, let's say. All right, so I'm going to substitute into equation number 2. And that's going to get me 2 equals 9 times 13 over 54 minus 3b. Now, 9 goes into 54. 54 divided by 9 is 6. And then from here, moving it across becomes, draw a line here. So 3b, I'm going to move this across and I'm going to subtract 2 on this side, right? And I'm going to change 2 into 12 over 6. So I'm going to end up with 3b equals 13 over 6 minus 2. And I'm changing that into 12 over 6. So I can have a common denominator and get 1 over 6. And then divide both sides by 3 gets 1 over 18. And that's going to be my b value. So I got my a value, I got my b value, and I got my c value. So I can now find my final equation for this. And my final equation is going to be this. Let's put it over here. Final equation will be y equals to 13 over 54 x squared plus 1 over 18x minus 5. And now I can solve to get x1 and x2. All right, so there's still one more thing that I've got to do here, which is solve to get x1 and x2. And I can use the quadratic formula to do that. I get the quadratic formula, which will be minus, and here I have to be super careful because I'm dealing with fractions. So if I'm dealing with fractions, I've got to be super careful. It's going to be minus b, remember, so minus 1 over 18 plus minus the square root of b squared, which is 1 over 18 squared, minus 4 times a times c, which is 13 over 54, times negative 5, all divided by 2 multiplied by a, which is 13 over 54. Grabbing your calculator and carefully putting it in, pressing your fraction button, and keeping brackets in mind whenever you're dealing with complex stuff like this, like 1 divided by 18, put it in a bracket, then put plus or minus after that, square root, keep the bracket going, 1 divided by 18 squared, b squared, minus 4 times a times c, 4 times 13 over 54, times by c, which is minus 5, divided by 2a, which is 2 times 13 over 54. And this comes to two solutions. So the first solution I got here is the following. It's going to be x equals to a positive value 34.9, and then I keep it on my calculator, just change it into a negative, and I get negative 35.1 for my two x values, just using the quadratic formula and then getting two solutions for x. Right. Quite a complex question for this one. So, yeah. Quick recap on this. Let's just make sure we understand what happened here. The first thing we did was we were given the graph and we were given 3 points. We were given 1, 2, 3 points. We then went ahead and dealt with 1 point at a time. We started just finding the c value. After we found the c value, we then substituted another point in there, and then we got the equation 1 in terms of a and b. Then we substitute another point in there, and we got equation 2 in terms of a and b. Then we substituted another point as well in there, and that was a equals, well, actually we substituted all 3 points in, and we got the two equations and we solved it simultaneously using the process of elimination, getting my a value, and then after that substituting it into one of the equations, getting my b value. And once I did that, I then substituted it into each component of my equation, which is there, 1, 2, and 3. And then quadratic formula got me my final solution there. All right. All right, so quadratics in terms of parabola, this time we're given the graph and we got to find the equation. All right, looking back at where we at, we had some equations, we'd solved that, some more equations, and now we just did a little bit of a graph for this. If you get given a graph and you get asked to find the equation, you can find or solve the equation. Remember, whenever we solve an equation, we're trying to find the x values. So if I'm given a graph that looks like this, and this is y, and this is x, and I know that this is x2, this is x1, and let's say this point is -4. Let's say there's another point over here which is 2 and -6. For this particular graph, we have it in vertex form. All right, so we have it in this over here, this point over here is known as your vertex. So when you complete the square, for a quadratic, you convert the quadratic from y equals to ax squared plus bx plus c into the vertex form, y equals x minus p squared plus q, in which case your turning point will be pq. So from here, I can see that's my turning point, 2, -6. And so I will have y equals to a x minus p, where my p is now 2, right? So x minus 2 squared minus 6, because that's going to be my other value. And all I need to do now is find a. So I can substitute a point in that I have. And the other point that I have is 0, -4. So I put 0, -4 in here. And I get -4 equals a times 0 minus 2 squared minus 6. So -4 equals to 4a. Minus 6 can actually move across and become plus 6. That'll become 2 equals 4a. 2 divided by 4 gets me a half. And so a will equal a half. And we can then put this all back into the equation and get y equals to a half x minus 2 squared minus 6. And that's the equation in turning point form, in vertex form. All right, so it's the vertex form of the quadratic. We could multiply the bracket out, simplify it, and then that's what we would get it into the original form, like that, if we ask for it or if we need to do that. So remember, for this one here, we just have to get the turning point. So we substitute there, turning point. 2 substitutions. Turning point is the first substitution. And the second substitution is another point. Okay, so we substitute turning point, and then we substitute another point, and we're done for this one. So why don't you try one of these now? I'm going to give you a graph with a turning point and another point, and I want you to find the equation. All right, this is just a sketch, not drawn to scale. This is my turning point, which is, let's say, 4 and -12. And this is the point -6. Let's see if you can get me. Find the equation for this in vertex form. Okay. In the form y equals a x minus p squared plus q. Okay. All right. So for this one over here, what we're going to have is, firstly, -6, 4, and -12. So the turning point we're going to put over here is going to be 4 and -12. All right. So that means x is going to be, p is going to be equal to 4, and q is equal to -12. All right. So that gets me y equals to a x minus 4 squared minus 12. Now, I need to substitute any other point in there. Now, this point over here, all I have is -6. So that means it's x equal to 0 and -6, because 0 is on this entire y-axis. All of these points will be 0. We then change x into 0 and y into -6. So -6 equals a multiplied by 0 minus 4 squared minus 12. And you can see we're trying to solve a. That's all we need for this. So we're going to get -6 equals 16a minus 12. 12 moves to the other side, becomes positive 12. -6 plus 12 is 6. And divide by 6 divided by 16 would be a. So therefore a is equal to 3/8. And so our equation, our final equation for this would be y equals to 3/8 x minus 4 squared minus 12 in turning point form. All right, and if we have to get asked to write it in the other form, remember, we just got to square out the brackets for that. All right, so let's try another one. The next one, it's going to be going the other way. It's going to be a bit sad face. All right, so I've got something that looks like this. Goes all the way around, and it turns at the point 3, 3. Have a look carefully at this graph, and I want to find the equation for this graph. All right, so I want to find the equation of this graph. Try it. All right, here we go. So this part over here, we're going to start off with the turning point form of the quadratic, which is y equals ax minus p squared plus q. And the first thing we're going to do is we're going to get these two values, which is the p and q value. And we get it straight from there, which is my turning point or my vertex. That's going to be x and y, and that's actually going to be p, and that's going to be q. P equals 3 and q equals 3. And we substitute it in a x minus 3 squared plus 3. Now I need to get the a value for this, but I don't have another point. And I can see that this goes through that point over there. So there's a hidden point over here, 0, 0. So that's the point I need, 0, 0. Make x 0, make y 0, find a. So it'll be 0 minus 3 squared plus 3. Taking this across becomes negative 3 equals a times 9. And negative 3 over 9 becomes a, which is negative 1 over 3. And so that's going to be my a value. So therefore y equals to negative 1 over 3 x minus 3 squared plus 3. Final equation in turning point form, in vertex form. I could use the quadratic formula and get my other x value, but there could be another way. How do I find this other x value over here? I could use the quadratic formula. I'd have to multiply this out, get it into the form ax squared plus bx plus c, and then use the quadratic formula minus b plus minus the square root of b squared minus 4ac over 2a, which seems quite tedious, right? The quickest way to get this, remember that if it's a parabola, then this is a line of symmetry, in which case the distance from here to here is the same distance from there to there. So this value over here has the x value of 3 from there. So this x value will be 6. In which case, I can see that those are my two x-intercepts. X equals 0 and x equals 6 are my two roots for this equation over here.